Okay, so I selected a few problems to go over with you to help you be able to answer the classroom assignment on 3.1. One of the problems I selected was number 9 from the textbook. It's asking to sketch and analyze the graph of each function and then give the domain, range, intercepts, asymptotes, and behavior, and where the function is increasing or decreasing. So if you take a look at this function here, I know it's going to be exponential growth because there's a 2 to the x. That number is greater than 1. So if b is greater than 1, it's going to be growth. I also know that the function is going to be shifted 3 units down, which means the horizontal asymptote is going to be y equals negative 3. For the parent function, a number to the x power, if there is no vertical shift, meaning if you're not adding or subtracting anything here, the horizontal asymptote would be y equals 0. You can clearly see if you enter this function on decimals, and then you can pull out the table and see what values you have for y for any given axis. So if you let me scroll this down. All right. So this would be a table that would be able to see either on a graphing calculator or on decimals. And what your graph is going to look like, since I know it's growth, it's going to go up. You can see some points plotted. So as far as the end behavior go, as x is approaching negative infinity, y is going to approach negative 3, or the horizontal asymptote. As x is approaching positive infinity, then f of x is going to approach positive infinity as well. As far as finding the intercepts, you should substitute a 0 for x to find the y-intercept, and 2 to the 0 is 1. Anything to the 0 power is 1. 1 minus 3 should give you a negative 2, which should be the y-intercept. And if you are looking for the x-intercept, you should look for a value on the table for x when y is 0. Okay, or you can just ask for that intercept. So here are the answers. Domain and range, as you can clearly see on the function, the domain of the function is all real numbers. The range would be anything above negative 3, so negative 3 to positive infinity, not including negative 3. So you have all your answers there, and it's increasing throughout. It's exponential growth, and is positive. For number 20, you're being asked to compare those two functions. The parent function is e to the x. You should know that natural base e is greater than 1, or 2.17. So here you see a negative, which means this function is going to be reflected, and it's also going to be shifted 4 units up. That's what I see. So instead of the horizontal asymptote being 0, it's going to be positive 4. So if you put this on the calculator, it's going to go like this. So it's a reflection, and it's going, the horizontal asymptote is going to be positive 4. And from there, you can pull out all the characteristics of the graph, which in this case would be the end behavior as x approaches negative of infinity, f of x would approach positive 4. As f of x approaches, as x approaches positive infinity, f of x would approach negative infinity. It's decreasing, and that's pretty much all they're asking. Domain is going to be all real numbers. Range is going to be anything that is under positive 4. So you can see all those characteristics there as well. All right. So it says it's reflected in the x-axis and translated 4 units up. Okay. You also need to know the formulas for compounded interest, and when it's continuously compounded. So a continuously compound it's going to be the PERT formula. This is in your textbook. Um, Compounded interest is going to be this formula over here. So essentially, just substituting values, the amount earned is always going to be equal to the principal times 1 plus the rate. Remember, if the rate is given to you as a decimal, sorry, as a percent, you have to change to a decimal. So in this case, I can clearly see that the principal invested was 5,000. 1 plus the rate here is 6%. I know that because as a decimal, it's showing up as 0.06 over 1, which means it's being compounded once a year, and times the number of times compounded, which is 1 times the time. The time they want you to calculate for is 30 years. So that's what you substitute there. And then you can put on the calculator and evaluate. Okay. As far as using continuously compounded interest, you'd have to use the principal, which is 5,000 times natural base e to the or t, which should be the rate is 0.06 times the number of years, which is 30 years, and then you can get your values from there. So that is compounded interest, continuously compounded interest. And then I also selected one word problem here. It says the consumer price index is an index number that measures the average price of consumer goods and services. A change in the CPI indicates the growth rate of inflation. In 1958, the CPI was 28.6, 2008 was to 11.08. Determine the growth rate. So you're going to use those years, and you're going to use that to write an exponential equation to model the situation. And then you have to predict what the CPI will be in 2015, and if it would exceed 350. So when you look at this, this is the formula you're going to need to have. You should know that the final amount is going to be the initial amount times 1 plus the rate to the t. Okay, so if you're trying to determine the rate, you substitute the other values in, and then you do use your algebra skills, divide by 28.6, and then take the fifth root and subtract 1. That's going to give you the rate. And once you have the rate, you can substitute in the formula, and which is going to look like this right here. And once you have that formula, you can calculate the value for any amount, essentially. Okay? I hope this helps.